like start listing my credentials or where I work or the very long, crazily long titles that I have. Sometimes it is embarrassing to say them out loud. But I teach at the University of Miami, as you know, and I focus on data visualization. And what I'm going to try to do in the next X number of minutes, let's see how long we can go, is to give you a very broad introduction to the title says, how to make good choices or good decisions in visualization, and which is something that I want to write about at some point. Probably the next book that I will publish, hopefully around 2022, will be related to these issues about how to make decisions in visualization. Now, one of the titles that I have now, that I know that I'm talking to data science, well, I know that already, right? But I'm presenting it to an audience of data scientists, is that one of the jobs that I have at the university is at our Institute of Data Science and Computing. I am the director of visualization at the center. And when they offered me the job, I said, well, yeah, I'm always happy to help, but I'm not a data scientist. I'm not a data scientist. I'm not a computer scientist. I'm not an engineer. I am a journalist. And they reacted, people at the center reacted saying, but what you do is part of data science. It's also part of data science, right? The way that you use graphics to communicate with people, that's also part of data science. And I realized that is actually at least partly true. The other day, for instance, I saw this very funny cartoon that what people imagine from the outside, when we see data science from the outside, the perception that many people have about data science is that data science in the real world spend 100% of the time creating machine learning models. But when you go to the reality, of the workplaces, actually creating machine learning models occupies just a very tiny percentage of the time of a data scientist. Most of the time is used to, first of all, identify the problems, define them well, finding the data, cleaning up the data, getting it ready for analysis, doing the analysis itself, coming up with the conclusions and so on, inferences, etc., and then communicating those results in a concise manner. And that's where my work comes in, because visualization can be used for either exploration or for communication or for both, right? Some people who work in visualization focus on how to use particularly interactive visualization for exploratory data analysis, extracting patterns and trends from data, and then coming up with ways to analyze that data further using the visualization sort of like a gateway towards better research and better conclusions. But then graphics can also be used, charts, maps, graphs, etc., can also be used to communicate your results. So I just wanted to bring up this cartoon because I found it really, really funny. But it is true that also that visualization is sort of like exploding in its use, right? It's being used everywhere and in many different realms. Now, before I proceed, by the way, I'm seeing that we are only 20-something people in the room, so that's a relatively small class. Something that you may have noticed already is that I speak nonstop, and that's sort of like a failure of mine. I love this stuff, so I can talk about visualization for many hours straight. But as long as we are a small group, what I'm going to ask you is not to wait until the very end. If you have a question that appears in the middle of the presentation, don't be afraid of interrupt me at any point. I can improvise if you have a question in the middle. Or I can just go straight until the end of the presentation, and then we can do a Q&A. I think that we schedule 1 hour for this, but I can stay a little bit longer if it is needed for that, okay? Anyway, so yeah, I think that we are living through a second golden age of visualization. Why second? Well, because the first golden age of visualization was the 19th century. If you read about the history of data visualization, you will learn that many of the best works in the history of data visualization were made in the 19th century by scientists, statisticians, healthcare professionals. The famous Florence Nightingale, who was a nurse in the UK, a director actually of nursing in several hospitals, and one of the main figures in the history of public health. She created many beautiful visualizations, and many other names, like John Snow, Charles Joseph Minard. All those figures come from the 19th century. But right now we are going through a second golden age of data visualization, which actually began many years ago. It began around the 70s or the 80s of the past century with the work of several statisticians, for example, John Tukey, one of the main figures in the history of modern statistics, who actually wrote a book titled Exploratory Data Analysis. And that's when the second golden age of visualization began. Now, in the world that I come from, the world of journalism, visualization is exploding. I mean, if you're following the news about the upcoming election, or COVID-19 for that matter, you're probably seeing data visualizations everywhere, right? All media organizations are investing in creating graphics, and one of the reasons why that happens is that through their analytics, media organizations are seeing that people, readers, love to see graphics. They love to see visualizations. Actually, many of the most popular stories ever published by many media organizations are data visualizations. The most popular story ever published by the New York Times online, most important newspaper in the country, is a data visualization, commonly called the dialect map. Later, when I share the slides with you all as a PDF, you will be able to click on that link and visit it in case that you have never seen it. It's a wonderful piece in which you can sort of like input your own, the way that you say things in English or that you pronounce words in English, and what you will get in return will be a customized map that will pinpoint where you're probably from, depending on the type of dialect of American English that you speak. More recently, the Washington Post, the most popular story ever published by the Washington Post online, is also a data visualization. In the whole history of the Washington Post online, this project quickly became, published at the beginning of the pandemic, this same past March, quickly became the most popular piece of content ever published by the Washington Post online. Probably some of you have seen it, but it's an explanation of how a pandemic spreads in a population, depending on whether that population doesn't take any containment measures, in comparison to whether that population takes measures to control the pandemic. And they simulate the spread of the pandemic using circles that touch each other and pass the virus onto each other as well. Very quickly, again, the most popular piece of content. Very recently, by the way, I read an article by the Washington Post saying that this is not just the only thing, the only graphic that became extremely popular in the past few years. I stumbled upon this story published by the Washington Post the other day that said that out of the 7 most popular stories that they have ever published in the history of the Washington Post online, out of the 7 most popular stories, 6 of those were graphics stories, were stories that were produced by the data visualization desk at the Washington Post. They don't produce just data visualizations. They also produce explanatory infographics that are made by of illustrations. But a great part of their output is data visualization. So this presents a huge opportunity, in my opinion, for people who want to get into this world. Data visualization can become a career. You can become a data visualization professional, and there are job prospects for that. But the way that I approach visualization is not that, right? A majority of my own students, for example, are not going to be formally called data visualization designers. That's not the way that I teach my classes. The way that I teach my classes is to tell my students that data visualization is a skill that works like writing, right? Everybody can benefit from learning how to write. Probably you're not going to become sort of like a Nobel Prize winner literature author, right? But you can write decently well. And being a good writer can help your career quite a lot, right? Same thing with data visualization. Being able to visualize the data well can benefit everybody and anybody. Not only because it will help you communicate better with other people, but also because data visualization is a very powerful thinking tool, reasoning tool, exploratory data analysis. Sometimes you don't detect patterns and trends in data if you don't visualize those data. Now, how to design visualization well? Well, for many years, data visualization, particularly back in the 80s and the early 90s, data visualization was approached as if it could be taught as a set of rules. Do this, don't do that, right? Those of you who have read some early books about data visualization, probably you have heard about a myth that says that we should never use pie charts. Well, it depends, right? It depends, right? Visualization, like writing, it is based on a system of symbols, and it is also based on a syntax, on a grammar that sort of like guides you on how to arrange those symbols, how to use those symbols, right? In visualization, we talk about geoms, the objects that represent the data. We talk about encodings, which are the properties of those objects that vary in proportion to the data, like in a rectangle, for instance. In a bar chart, what you do essentially is to get a bunch of rectangles and then vary the length or the height of those rectangles to represent the data. The encoding in a bar chart is height or length, depending on what the orientation of the bar graph is, right? Everything that I'm saying right now here is related to that grammar of graphics, right? Grammar of visualization. There's actually a whole book written by a visualization author titled The Grammar of Graphics, right? Which describes all these properties. But what I'm getting at is that after we learn that grammar, right? Like in writing, after we learn how to write well, then the ways that we write can vary a lot. And the ways that we visualize can also vary a lot. Therefore, visualization cannot be taught as a set of rules that are set in stone. Rather, it should be taught, I think, based on learning how to reason about visualization, how to come up with good reasons to make choices when we design visualizations. Now, everything that I'm saying is related to, again, the book that I'm planning to write in the future, which probably will be a book that will touch upon the literature on ethics, on the philosophy of ethics. People who write about moral philosophy talk a lot about reasons, giving yourself justified reasons to do something against doing something else. One of my favorite authors in the literature of moral reasoning is Derek Parfit, who has a wonderful book titled On What Matters, in which he defined reasons, right? He says, facts give us reasons to do something when they count in favor or against having some opinion, having some desire, or act in one way or another. I think that this is the right way to teach how to make visualizations. When you would design a visualization, you need to think about critically and consciously about what you are doing. You need to ask yourself a series of questions, right? So probably my next book will be sort of like structured around the different questions that I think that we should ask ourselves whenever we design a graphic, particularly related, particularly a graphic intended to communicate something, not necessarily a graphic for exploration, but a graphic for communication. Now, the first question is the most obvious one. I'm going to go over just a few of them, not all of them, 5 or 6 of them at the most. The first one is very obvious, a no-brainer. Why should my visualization exist in the first place? Do I need a visualization, right? Well, the answer to that question can be answered in different ways. First of all, it's like, do we need to decide whether we need to show the data set in tabular format, or we need to transform the data set into a visualization? How do you make that choice, right? Well, in general, as in almost everything else in visualization, it all depends on the purpose that you have in mind. This is a very famous data set of average global temperatures all over the world, from the year 1000 up to the year 2000, measured in Celsius degrees in comparison to an average of the 20th century. That's the reason why you see negative values and positive values. That means above the average or below the average, obviously, right? Now, when should you present a data set like this in tabular format? Well, the answer is when you want your reader to be able to locate and identify specific values, right? So if you want your reader to be able to see what the temperature was in 1885, you better present your data as a table so people can quickly crisscross columns and rows and find that specific cell with that specific value. But what if the purpose of the graphic that you're designing is not to be able to locate specific values? What you care about, what if what you care about is displaying the big patterns, right? The big trends in the data that may hide behind all these numbers, and answering questions based on those patterns. Well, obviously you should not present the data in tabular format, because if you do that, nobody's going to be able to identify those patterns. A very simple question that we could pose based on these data set is, have temperatures increased or decreased in the past 1,000 years? Well, we know that they have increased. The global temperature all over the world has in general increased, right? We know that. But if we didn't know that, and we present the data in tabular format, we will be forcing our reader to navigate through the entire data set and compare the last number to the first number. More difficult question, what if we want people to be able to see whether at any point in the past, the temperature of the world in general was higher than it is today in the most current date? That is even harder. You would need to navigate the data set several times in order to take a look at all those numbers. How easier it is to answer all those questions if we transform the data set into a simple time series line chart, right? That sort of like collects all those data, makes the data more physical in some sense. It almost makes the data touchable for some reason, right? So the data is displayed as a blue line and a red line. Those are the point estimates of what the temperature was. It also displays the level of uncertainty because obviously this is all based on proxy variables. We cannot observe, we don't have records of temperatures from the year 1000, right? So what climate scientists do is to reconstruct those temperatures based on proxy variables, such as, for example, tree ring growth patterns. If you cut a tree and you take a look at the rings inside, depending on how big or how small they are, you can sort of estimate what temperature that tree was experiencing at that point in its growth. But obviously that proxy variable is very imperfect, right? It adds a lot of uncertainty to the proxy variable, and that's the reason why the uncertainty is so high in the past. But in any case, the patterns that hid behind the data before become clear once you visualize them, right? Temperatures remain more or less stable, right, within a certain, very wide, but a certain range in the past, but they spike up very rapidly beginning on the 20th century. And if we extend this line towards the present, closer to 2020, the line continues increasing. That pattern was not identifiable in the data set itself. It only becomes obvious, conspicuous, unavoidable. You cannot unsee it once you have seen it, right? Only when we transform it into a data visualization. So this is the case when you know that you need a data visualization, when you care more about the big picture, the big patterns, the big trends in the data, than you care about the specific values. Now, in some cases in data science, you care about both. You care about the big pictures and you also care about the details. Therefore, you would need to present both the table, both the chart and the table together, if possible, because then you will accomplish the best of both worlds. The question of why should my visualization exist also has an ethical component. Let me show you an example. I'm collecting examples that I will probably write about in the future. Back in 2012, the journal News, which is a newspaper in upstate New York, published this map that you have on the screen right now. It was published a few days after the terrible mass shooting at Sandy Hook Elementary School in 2012. Terrible, terrible event. A few days later, the journal News, this newspaper in New York, published this map. Each one of these dots represents one person. What types of person? A person who has a gun permit, a handgun permit in upstate New York. Each one of those dots is a person. When this map was published, right, it's not published anymore. It's not available anymore. There are only screenshots right now because it caused an uproar, right? The journal started receiving a lot of complaints. The newspaper defended itself, saying, we felt that sharing this information was valuable to our readers in the aftermath of the mass shootings. Now, I'm not going to get into the details about why I think that this is wrong to publish a map like this, but it's a great example to illustrate this idea of asking always why? Why should I make this available, right? What purpose does this visualization accomplish? Should this data be made public? And more importantly, if we still believe that the data should be made public, should it be made public this way? Aren't there other types of maps that, for example, could aggregate the data at a higher level rather than pinpointing every single person? Couldn't we aggregate the data at a higher level and show areas, right? Like in a choropleth map, which is a map that uses shade of color to represent, for example, rates, concentrations of people who have guns or not, gun permits, by the way. These are not gun owners. These are people who have gun permits, which is different. That's also part of the problem with that map, that you're probably putting here people who don't even have guns at home. So even if we decide to publish this map, we always need to weigh the possible benefits of publishing the visualization versus the possible harm that that visualization may have. And whenever it is possible, if our data represents people, right, maybe we should consider asking the people being represented in the data what they think about this visualization. Probably many of you who have some sort of relationship with the tech industry have heard about the famous trolley problem in moral reasoning, right? The trolley problem is one of these mental experiments that philosophers come up with sometimes that says, for example, you're on top of a bridge and you see that there is a train approaching 5 people and the train is going to kill those 5 people. And then you have a lever on top of the bridge and you can pull it. But then if you pull it, the train will go to the other side and it will kill instead of killing the 5 people, it will kill one person, one fat guy who is on the other side. And then in another version of the trolley problem, that fat guy is on top of the bridge And then the experiment says you can push the fat guy in order to stop the train, and then you will stop the train, you will kill the fat guy, but you will save the other 5 people. The entire books have been written about this trolley problem. But what I always wonder is, why doesn't anyone ask the fat guy what he thinks about the problem, right? That this is similar, right? Why don't we ask the people who are being represented in the map what they think about being represented in this way, in this particular map, right? We need to think about the people who are being represented in our numbers, right? That can help us answer that question. Should my visualization exist? The second one is what to visualize. What to visualize in the sense of, do I understand what is being measured when I'm creating this graphic? One of the stories that I often use to illustrate this problem, or do I understand the limitations of my data or the different uncertainties that my data may have? Years ago, a student of mine, Luis Melgar, who is now a visualization designer at the Wall Street Journal, he was working in his capstone project in class, and he did a visualization about homelessness in Florida. And he downloaded, he went to the Florida state government, he collected tons of data, talked to experts, right, to explore homelessness in Florida. And he decided to focus his project, his investigation, on homelessness among students, student homelessness in Florida. Anyway, he collected the data, he visualized the data. He came to my office one day with several charts that completely shocked me. They shocked me. When I saw these two maps, for instance, I was absolutely shocked, because as you can see, this map is showing that there are certain counties in Florida where more than 5,000 students are homeless. So how is that even possible? That's a lot of people. And then when you take a look at the percentages, there are counties in Florida in which more than 20% of students are homeless. I say, this is impressive. I mean, this is a humanitarian crisis. And then Luis reacted to that saying, yeah, sure, there is a problem here. I mean, the Florida's government is trying to deal with this. This is a problem, but you need to take into account that I have not told you yet what it is that the state of Florida calls a homeless person. Because probably when I said the word homeless, you jump to conclusions immediately, right? Your brain had a snap reaction, and what you imagine is a homeless person is someone who lives on the streets. And that is not what a homeless person is to the state of Florida. To the state of Florida, and probably to other states as well, a homeless person is someone who doesn't have a permanent home. That means that if a student, for instance, comes from a poor family, and this student needs to change homes several times all year round, that student may have a roof all the time over her head, but the fact that she doesn't have a permanent home may mean that she will become part of this database, right? That doesn't render the database wrong, but before we understand what it is that we're going to visualize, we need to understand the definitions of what it is that we're visualizing. Now, this is probably a no-brainer to all of you because you're all data scientists, but there's another side of the coin. If you want the reader to understand what it is that the graphic is representing, you better explain it. I have seen tons of dashboards, visualizations created by scientists, etc., that display the data beautifully, but then don't explain what that metric means. They just use the word, in this case, homeless. I say, okay, but what do you mean by that, right? It's similar to what happened with COVID-19 at the beginning of the pandemic. Number of cases. But how do you define that? Is it number of cases confirmed? Is it number of cases tested? What is it that you mean? You need to explain that, right? That explanation needs to be sometimes, very often, it needs to be written, a written explanation. We call that the annotation layer, which is an essential part of data visualization. I will get to that in just 1 minute. But before I get there to the annotation layer, I would also like to talk about uncertainty, because at least in the world that I come from, the world of journalism, we have sort of like a little bit of an allergy to display uncertainty in our graphics. And that's a huge problem, because sometimes it may lead us to publish headlines and stories that are completely wrong. This is in Spanish, but I'm going to translate it for you. This comes from El País, which is the most important newspaper in Spain, my country of origin, right? It's the equivalent of the New York Times in Spain. Most important, most serious newspaper. You know that there's a region in Spain called Catalonia, and Catalonia has a very strong a movement for independence. Half of the people of Catalonia wants Catalonia to become an independent country. The other half of people in Catalonia doesn't want Catalonia to become an independent party. And the thing is that the regional government of Catalonia every year conducts a survey asking Catalonians several questions about the state of the nation, right? Do you like this? Do you like that? What do you think about this? One of the questions is, do you want Catalonia to become an independent country? Well, El País got the latest results in 2013, and they titled a story, "The no to independence in Catalonia is higher than the yes to independence in Catalonia since 2012, right? It's the highest difference since 2012. And the story contained a graphic. It was originally a pie chart, but I transformed it into a bar graph just to make the point that I'm about to make. They said, well, a majority in the region will reject a secession, separation from Spain, if a referendum were held now. Well, this is wrong for several reasons. First of all, when you take a look at the data, you will notice that that is not a majority. It's a plurality. That's different. It's 45.3% of the people in Catalonia rejected in this survey. They rejected independence. 44.5% on the other hand were in favor of independence. But then you also have 10% of people who didn't express their opinion. That adds uncertainty. The other problem is also that when you read the story, and I did, and actually called El País out and sent an email to the director of El País because I saw the title online, and I said, you should not publish this headline. That headline is wrong. You cannot put it on the paper, but they didn't listen to me, and they ended up putting on the front page of the paper 4 columns, huge columns saying that the no was bigger than the yes. What alarmed me was that if you read the story, there was a portion that says the margin of error of the poll is 3 points, and then they say a relevant fact, considering the tight difference between the yes and the no to independence in Catalonia. And the point that I was trying to make to them, and sometimes journalists are a little bit resistant to this, is that you cannot safely claim that the no is bigger than the yes when the margin, when the confidence interval is so wide and the difference is so tiny between those two numbers, because that could be just simply the result of, I don't know, polling error, for example, right? So the natural variation of data, right? All that you can say is that they seem to be tied. That you can say that they are tied, but saying that one is ahead of the other is a little bit dangerous. So as data scientists, I think that, and I apply this to myself as a journalist also, I think that we need to think about also of ways of representing our data in more uncertain ways, right? Perhaps fuzzying the boundaries of objects, or showing the ranges of uncertainty around our point estimates. Now, this could be an entire book and another entire lecture on its own. So I'm not going to continue talking about uncertainty, but probably many of you are interested in how to communicate uncertainty and visualizing uncertainty. So if that is the case, when I share the slides with you all, right after I finish talking, this slide here, the link that you have down here will take you to a public Dropbox folder that I have, in which I am collecting the work of many people who are working in this problem. Researchers who are studying how people perceive uncertainty, how to communicate uncertainty better, how to display uncertainty better. I have a huge collection of readings over there, organized in different folders, just to make it a little bit easier. So it's a little bit of a rabbit hole though, because you can spend many hours reading about this, but there's a lot of good work being done that deserves a lot of visibility. And I really want to give it the visibility that it deserves, because we really need to deal with this problem. How do we show people that the charts that we create are actually not as precise as they look? That's the problem, for example, I have with line charts and bar graphs, right? The boundaries of those objects are so neatly sharp, right? That is very easy to sort of like infer accuracy that is not really there. So how we can deal with that? That's one of the ongoing challenges in data visualization. I don't have a solution myself, but you know, with the collective power of many brains like mine and yours all together, perhaps we can come up with the right solutions to that conundrum, to display uncertainty, but also on the other hand, also how to display confidence. When we are confident about something, we should also emphasize that we are confident about something. Then we need to consider also who to visualize for. And this is related to what I was saying before about explaining things to people, right? One of the challenges that I always face when teaching visualization, particularly to statisticians and scientists, is that there is a widespread myth among scientists that when we create a graphic, we should only create the graphic. We should let the data speak for itself, scare quotes in there. Let the data speak for itself, just show the data. Well, that is appropriate if you're presenting your graphic to someone who works in the same field as you do. because then that person you are presenting the graphic to will be able to read the graphic, because that person will come to your graphic with the same pre-existing knowledge that you have to read the graphic correctly. But if you show the same graphic, yeah, dealing with your research, the research are involved in, if you show it to me and you don't explain it to me, I will not understand crap. You need to explain it to me, right? That's the annotation layer at work. Look, at the beginning of the pandemic, Brian Stelter, who is a famous TV newscaster from CNN, he showed the famous flatten the curve diagram. But fortunately, he didn't just show the graphic on the screen and moved on and talked about something else. No, he took the time to show the graphic on the screen and teach the audience how to read that graphic, emphasizing what the graphic means and how to read it. That's the annotation layer at work. When we use a graphic that is, we believe, that is unusual for our readers, unexpected, or too complex for our readers, we should use it because it's probably the best way to represent the data, but we should also take the time and the effort to try to explaining a little bit to our audiences. The best example to learn how to do this well, I think, if you need some inspiration, how to add an annotation layer, explanatory annotation layer to your graphics, is the work of Hans Rosling. Hans Rosling, for those of you who had never heard of him, was, because he died a couple of years ago, unfortunately. Hans Rosling was a professor of global health in Sweden, and in my opinion, he was one of the most successful, one of the most engaging presenters of data that I had ever seen. He was someone who showed very complex data sets and graphics in his presentations, but he was able to make his data sing and speak and talk and be fun and exciting, because he became part of his graphics, putting himself in front of his visualizations and explaining to audiences of all kinds and all educational levels how to read those graphics. He has a wonderful documentary that is publicly available. All these videos are publicly available on his website. In his website, gapminder.org, you can find it. It's titled "The Joy of Stats." He did it for the BBC. And in one of the scenes of that documentary is the one that I'm going to present right now. Rosling appears on the screen, and then he says, well, I'm going to talk a little bit about the world. But before I show you anything, there's going to be a y-axis, a vertical axis. And this vertical axis is going to represent the position on this vertical axis is going to represent life expectancy. And then there's going to be a horizontal axis. The position of objects on the horizontal axis represents the wealth of these countries. So if you're down here, it means that your country on average is poor and sick. If you're up here, it means that your country on average is poor, rich and healthy. Now let's take a look at where the countries, all countries were in 1810. Let's make them appear, right? Each one of the colors is going to represent one continent, right? That's the other encoding. We are using color to identify the continents. And then the size of the bubble, that's another encoding. The size of the bubble is representing the population of those countries. As you can see, they are on the bottom left corner. That means that life expectancy is really low, and most countries in general tended to be quite poor. Only the United Kingdom and the Netherlands were a little bit of ahead of the rest of the countries. But if we start moving the world towards the present, you will notice that the countries will start moving more and more and more towards the upper right corner, meaning that life expectancies increase little by little and wealth also increase little by little. Now, when people praise Rosling, they rightly point out how engaging a speaker he was when he was explaining the data itself, right? Because in the middle of the presentation, he stops and he points out a particular country and he says, here is China, and this happened in China, this is Japan. So he was using his fingers and his voice to emphasize the important points of the data, which is one of the functions of the annotation here, whether it is spoken or written. We should also emphasize what is important in the data. But for me, what makes this absolutely outstanding is that the first thing that he did is not to show any data. The first thing that he did was to explain how to read the graphic, right? He explained the grammar of the graphic, vertical axis, horizontal axis, color, and then position. He was explaining the encodings of the graphic, right? So those encodings, some people will not know or would not know how to read them, but if you explain it to them, they will be able to read them. Now, some people who work in visualization believe that these explanations are one of the most important elements in any visualization that is designed to communicate ideas to other people. A while ago was an interview with John Bourne Murdoch, who is one of the data journalists at the Financial Times. And John said, we believe in the department, in the graphics department of the Financial Times, that one of the most important things that we do is not the graphic itself, it's not the visualization itself, it's the annotation layer. It's the fact that we pinpoint, we locate, we highlight what is important, and then we try to explain it whenever it is possible, obviously. We try to explain what's going on. So this is an essential component in any visualization for communication, and in particular, if you're communicating with people who are not in your same area of expertise. Obviously, if you're communicating with your peers, right, people who work in your same area, that's completely different, because other scientists who study the same things as you do, they will be able to identify the main points in your graphic and read your graphics with no problem, just because they come to your graphic with the same level of knowledge that you do, but other people like me won't. So you will better be prepared to do that. Another question is how much to visualize. And this is more a problem in my world, perhaps more than yours, because in my world, journalists, we tend to oversimplify things and show only measures of central tendency, only very highly aggregated measures. And sometimes that is appropriate, but sometimes it is not appropriate. It all depends on the nature of the data set. It all depends on, for example, whether a distribution is skewed or not, and so on and so forth, right? So I'm going to just sweep over this very quickly. One of the examples that I usually use to explain this problem is this chart, the murder rate in the US. The chart itself is not wrong. It's not wrong. It's the best data that we have, right? The murder rate in the US per 100,000 people, going up in the 90s, going down, and then going up again in the last few years. Many people read this graphic as the United States is becoming a more dangerous country just because they see the line going up in the past 2-3 years. This line has continued increasing. But that is misleading, because we need to understand this graphic correctly. We need to at least be explained or see the data disaggregated at a lower level, because what we're dealing with here is the following. Most places in the United States are very safe, right? If you can disaggregate this data, most places in the United States will be down here on the vertical axis, right? The murder rates in most cities, most towns, most neighborhoods, right? It's actually quite low. It will be around the national rate or below the national rate. Now, what is the challenge? The problem is outliers, right? There are certain places in the United States that have become so violent in the past years that they sort of like skew the national rate, right? So we have a very skewed distribution. So what is the level of detail that we need in a visualization? Should we show the highly aggregated metric, an average, a median, a mean, a mode, or a national rate or whatever? Or should we disaggregate the data down to the individual observations? Well, that's a range of possible levels of aggregation, right? It's like a range, right? Where should we stay in this sort of like this range between everything disaggregated, every single data point, or high aggregation, just the measure of central tendency? Well, the answer to that question, as everything in visualization, is it depends. It depends on the nature of the data, depends on the nature of the story, depends on what you want to communicate. It depends on a lot of things. In this particular case, if I were doing a visualization about these, I would still use this graphic, right? I would still use the national rate. But then if I could find data disaggregated, for example, at the city level, I will try to show the main cities just to explain to people, well, yes, sure, the national rate is increasing, but when you disaggregate by city, you will see that some cities are actually increasing much more than others. And if I don't have access to the disaggregated data, what I still will do will be to explain this verbally, the annotation layer. I will still show that, but then I will explain the fact that there are outliers that maybe sort of like changing the national rate a little bit. Now, when it is appropriate to go to a higher level of aggregation, when in a case like this is, for example, if all the observations were, let's say, very close to the national rate, a little bit up, a little bit down, but 99% of places were around that, the national rate, then you don't need to show every single observation, obviously. Just the national rate may be sufficient to tell the story. That's why I usually say that when we think about how much data we should show in a visualization, the answer is never more or less data. It's a sufficient amount of data, to reveal what that data truly means in your opinion. You are the one who has knowledge about these data, so you better make that estimate. How to visualize it? That's another question that we should ask ourselves. What
Right.
types of graphics? Yeah, go ahead. Sorry.
Sorry to interrupt. I think some people have some questions in the chat. So,
That gives me the opportunity to drink a little bit. So
oh,
I
okay.
appreciate that. Go ahead.
So would people like to ask their questions now during this slight pause, if there are any questions available?
Sure, I'd like to ask one.
Okay. I think you can.
Can you hear me okay?
I can hear you.
Okay. So that visualization showing it was like time versus income or age versus income in your
Yes.
countries. I was a bit confused just from the data alone. I don't know if we explained it in the video, but how if it accounted for inflation, like was $400 the same $400 it is today back in 1812, and just how you would kind of represent something that is variable like that, right? The value of money changes over time, how you would represent that as a static variable X.
I honestly don't remember, but the values are adjusted for inflation. That I know. I don't know whether he mentions that explicitly in the video, but the values come from the database from Gapminder, and the values are adjusted for inflation. If I had to present that myself, a graphic like that myself, I would make that explicit, saying I have adjusted these. These are values in 2020 dollars, right? I will adjust it. They will be adjusted to make them comparable. Yeah, but I don't remember whether it is explained or not in the video. You should go check it out. It's a very fun video, and watch other lectures by Rosalind.
Cool. Yeah, I think I will. I was wondering if you had any idea about something like this happening before, where there's a variable. Right, that you're looking at value of money that changes. Is there some other way you would represent it other than accounting for inflation and telling your viewers?
So can you say that again? If I want to show what?
So the variable is changing, right? $400 has different value throughout time. So it's a variable. It's not a constant. Is there a way you would change that, or do you think the best way to go about this is to say?
That is similar to challenges that we have, for example, when measuring, let's say, unemployment rates, right? That the way that we define unemployment has changed over time. Therefore, the variable sometimes changes according to those changes in the definition of the variable. The way to do that is to make breaks in your chart, to actually show gaps in your chart, and to actually annotate that there was a change in the definition of unemployment in this particular place. And that's the reason why we see a higher rate over here or a lower rate, just because the thing was redefined. In the case of inflation, one way to visually explain it is to show, for example, the variation of the price of a particular good or a particular service over time, adjusted for inflation or not adjusted for inflation, and show both, just to illustrate the variation of both. You can create, for example, an indexed chart, right? That begins at 0%, and then you show the percentage change, right? Going up or going down. And then you adjust it for inflation, or you don't adjust it for inflation. And then you explain why you adjust it for inflation. So again, there are no easy fixes or easy solutions, but they involve using breaks in your graphics, not making something look continuous when it is not truly continuous. Like in the example that I put about the unemployment rate changing definition, right? If it is not continuous, just do breaks in there. And always explain. Yeah, always explain.
Thank you.
No, thank you. Should I continue?
Yeah, I think
okay. Yeah, I'm getting to the end. I only have a couple of questions more, okay. But I think that you will appreciate these too. So how to visualize it? So I'm going to talk about one of the main mistakes that people make the first time that they design a visualization. One of the main mistakes is to work in autopilot. You open up a data set, you open up a software tool, say Tableau or R or Python or whatever, right? And you just go with the default solution that the software tool gives you, right? You open a data set and you mindlessly pick a graphic form to represent your data, and you don't think about it. That's not the way to choose your graphics, right? The way to represent your data, the type of chart that you're going to, or map or graph to represent your data. How you make choices? The answer is always, it all depends on what you want to communicate, right? And the same data set can be represented in multiple ways, all of them appropriate, depending on whether the purpose is. So quick example. This is a graphic that was shown to me years ago, super simple graphic, super simple pie chart, showing where migrants arriving to Greece in 2016, where they came from. And the people who designed this graphic, they asked me, do you think that this graphic is good or bad? I said, well, graphics, I would certainly work a little bit with the colors. I think that the colors are too, I don't know, Excel-y. I don't really like that, but that's sort of like my personal aesthetic opinion. But in terms of the structure, in terms of like the functionality of the graphic, it all depends on what it is that you're trying to show. I said, if you're trying to show in this graphic that perhaps the message is, let's suppose that that is the message. If the message is to show that half of these migrants came from Syria, and the other half came from other countries, this graphic is fine. The only change that I would make would be to emphasize that message even more by coloring Syria with one color and then coloring all the other countries with just one single color, rather than with multiple colors, just to emphasize Syria versus the others. But just for the sake of argument, let's suppose that, that the purpose of this is not to show half versus half, right? Let's suppose that the purpose of this graphic is to compare the countries to each other, being able to compare Pakistan to Afghanistan, Iraq to Syria, others to Afghanistan, Palestine to Iraq. You cannot really do that with a pie chart, or at least it's really hard. You need to squint, you need to use your fingers and see what proportion of these that represents. You need to use your fingers and say, well, that's around 1/4 or something like that, right? So pie charts are not great for comparison, right? Pie chart use angle to encode the data, the angle of the segments, and as an extension of that, or a consequence of that, the area of those segments is also proportional to the data itself. And we know empirically that angle and area are not that great for accurate comparisons. So if the purpose of the chart were accurate comparisons, maybe we may want to use a different encoding, a different way to represent the data, perhaps length or height, like in a bar graph. Perhaps a bar graph could be a better solution. I said, what if, but then let's put ourselves in a completely different scenario. What if the purpose of this graphic is not to show half versus half, it's not to be able to compare the countries to each other? What if the purpose of the visualization is to show where these countries are, and whether there is a sort of like a association between the proximity of these countries to Greece and the proportion of migrants who come from these countries to Greece? In that case, we may need a map. So depending on the answer to the question of that says, what is it that I'm trying to show? What is the task that I'm trying to enable? We could represent our data in 3 completely different ways, or in more ways, even in more ways, depending on the purpose. The map is not, well, by the way, so the label seems to be misplaced, but each one of the bubbles represents one of those countries. And then the size, the area of the bubble represents that proportion. The map shows you where the countries are. The pie chart emphasizes the versus half. And the bar chart, well, now you can compare the proportions of the bars, because the bars are much easier to compare to each other. Now, the reason why I use this very, very simple example all the time is that, as I said before, one of the most common mistakes is to work in autopilot. And this is what I mean. I know for certain that in my own classes, if at the beginning of the semester I give a group of students a data set in which all the data adds up to 100%, I guarantee that I can tell what type of graphic they will come up with, many of them. If I don't tell them what the graphic is for, most of them will design a pie chart. And then when I ask, why did you design a pie chart? Why? The question is why? Why did you do this? What is the reason that led you to design a pie chart? Remember that the visualization is all based on reasons. What is the reason that led you to design a pie chart? It's usually, well, because the data adds up to 100%. So, well, but that may not be a good reason, because you have not thought about what the visualization is for. That would be a good reason. Again, if the purpose is to show parts of a whole and then to compare the bigger segment to the rest, then the pie chart may be appropriate. But what if the purpose is to compare the countries to each other? Then you may want to shape the data differently. And the map is the same thing. If I give a beginner data sets that contain spatial variables, such as countries or counties or whatever, I tell design a visualization. Well, many of them will come back to class with a map. And sometimes maps are not the right solution. I love maps. I absolutely love maps. And later on, I will give you reading recommendations as an extension of this class today, to learn about cartography, which is one of the most overlooked areas in in visualization. We do need to learn about mapping, but maps are not the right solution all the time. It all depends. It all depends. So when you think about visualization, think that a visualization is an extension of your eyes and not your brains. It is a tool. It's a tool. It's like a pair of glasses, right? A pair of glasses. If I take them out, I don't see your faces. If I put them on, now I can see your faces, right? And the shape of the object, right, that is extending my vision has a particular shape because it has a particular purpose, right? The shape is associated somehow with the purpose that that object is intended to fulfill. My first book is titled The Functional Art for that reason. I think that visualization is an art, but it also has a very important functional component. We need to think about what the visualization is for. And based on the answer to that question, then we shape our data in one way or the other. Just to finish this section, and to extend or continue learning about these, there are many resources out there that can help you make better choices in terms of choosing graphic forms. The Data Visualization Catalog, for example, or this poster designed by the Financial Times a while ago, in which they sorted visualization forms, visualization types of graphics, according to the purposes that they're usually helpful to fulfill. I'm hearing someone speaking in the background. Is there any question? Anybody? No?
I don't think there's any questions.
Okay. I was just hearing someone like speaking in the background. All right, so last question. Visual design, right? What style? What is the style that I should use? Now, when I teach this type of classes to different types of audiences, I usually make the same joke. When I teach visualization to journalists, I tend to emphasize the statistical concepts and the reasoning about the numbers, and to show me the data as it should be. Don't oversimplify, right, the content. But when I teach these classes to scientists, I tend to emphasize this other part that is a little bit more related to visual design, right, to the design in terms of using typography and color well. Okay? So again, I cannot go in depth in this, but I'm going to just leave on the table the idea that do care about good design. And if you can, get yourself a couple of books about visual design to learn a little bit about how to use typography well and color well, etc. Because then your graphics will be brought to the next level, right? Now, this graphic over here is a graphic that I use sometimes to illustrate how you can make, with very minor changes, how you can make a good graphic look much better with very, very minor changes, only if you bother spending 10 or 15 minutes polishing the style of the graphic. This is extremely important. Many scientists believe, wrongly, I think, that polishing graphics and making graphics look beautiful and elegant should be an afterthought, because they say, I only care about the data. Let me show the data. If the graphic looks ugly, that's the reader's problem. Well, it is not. If you make your graphic ugly, nobody's going to take a look at it, right? So you better spend some time making your graphic look professional. This is a graphic that is okay, right? But it has many things that could be changed, right? So I usually say, try to polish it, try to think about the elements of your chart that don't fulfill any purpose, that have no purpose whatsoever, and eliminate them. And then think about whether you can rearrange text in different ways to make it look a little bit more readable. So things that oh, by the way, and also don't trust software defaults, right? In general, right? Most programs, software defaults are not that great, unfortunately, in terms of choosing colors and in terms of choosing fonts and so on and so forth, right? This is something that I emphasize a lot in my classes. Design what you want to design, not what the computer wants you to design. You should be the author of the visualization, not the computer. Sometimes computers make very bad choices, and I will show you an example of that in the following slide. In any case, how we can make a graphic like this look a little bit better, just by polishing a little bit, just 5 or 10 minutes. We could make the grid lines slightly lighter. I like grid lines. I think that grid lines help people understand the data better. But maybe we don't need that many, and we don't need them to be so emphatic, so visible that they sort of like compete with the data itself. We don't need the 3D effect and the perspective effect. Actually, 3D and perspective effects can be a little bit dangerous, because if you make a graphic that has perspective, it's hard to estimate how big, for example, the red segment is over here, right? Is it 82%? Or should we project this edge over the background and then we discover there's around 90%, right? It's a little bit ambiguous. Well, we can get rid of that ambiguity just by making the graphic 2D, not 3D, right? And then typography, right? A key rule in typographical design is things that are the same should look alike. Right? This means that if you have tons of titles in a research poster, for example, title for this section, for this section, for this section, they should all use the same style, right? Or they should all use the same style because they are the same type of object. Things that are the same should look alike. But the other side of the coin is that things that are different should look different. And in this case, on every one of these labels, we have two things that are different. We have the label itself, and then some sort of like clarification in parentheses. The label, the parentheses, the label, the parentheses, the label, the parentheses. But they are written on the same line. This is like if you copy and paste from Word, right? It looks chaotic. How better does it look like that, right? If we sort of like emphasize the difference between one thing and the other thing. Things that are the same should look alike. All these things look the same, but things that are different should look different. If we have two different objects over here, we should make them look different, right? So do care about design. Pay attention to this type of polishing. So if you spend time, for example, when you write a research paper, right, you spend time, hunting typos down and getting rid of them and polishing the language and making yourself more understandable, that type of editing is also extremely important in visualization. Let me show you a real case scenario. I got permission by the students who created this poster a while ago to show it in talks, is because the poster itself is good. It's a good research poster designed by students here at the University of Miami, but I used it once to illustrate how to begin with something that is already good, but through polishing and thinking about visual design, how to make it look better, right? And the process that I usually follow to make designs better is to first think about what I can safely eliminate without compromising the graphic itself, right? Things that can be eliminated. And then after thinking about what I can eliminate, I also think about things that I could add to the design to make the design more understandable or look better. There are many things here that can be eliminated. For example, the background boxes. Sort of like a rule of design about using boxes around objects is that if you box everything out, nothing will be highlighted. Only put something inside a box when you really want it to stand out. Otherwise, don't use boxes. Use more white space in between the sections. Things that can be eliminated over here. Let me just go here and do this because I'm not seeing my cursor. So I'm going to just do this to point out certain things. Let me just see this, if I can get my cursor back. No, I'm not seeing it. Well, anyway, you see the diagram there in the middle, those bubbles and the red square or something? When I saw it, I joked, I can tell what software tool you use for that, right? That's PowerPoint, I don't know, 1997 or something like that. It uses that style of PowerPoint, right? That blue and that red, etc. We can make that look better, right? Just with some rearrangement. And then I went to the map. Take a look at the map on the upper right corner, right? Well, first of all, that uses a color palette that is a little bit tricky. That's called a rainbow color palette. For many different reasons, rainbow color palettes can be a little bit tricky because they are often used to show continuous scales, but the color palette itself is categorical. It uses different colors. So it may make you see boundaries, thresholds in the continuous scale that are really not there, right? So the general principle in the design of these types of color palettes is that if the data is continuous, maybe the color palette should be continuous as well. But that discussion can take us very long. I have many readings to give you later on at the end of the talk that can help you understand what it is that I'm talking about right now. But the thing that I pointed out about that map, and I need to stop sharing just for a second because I'm not seeing my cursor and I need to have the cursor back. I'm going to share my screen again. And let me see if I can see my cursor. Well, it seems that something is wrong with my cursor. In any case, I'm spoiling. That was a spoiler alert. I'm seeing keyboard shortcuts. Sorry about that. Well, you see the scale here, right? Take a look at that. This is what happens when you let the software make decisions for you. Nobody is going to be able to locate the color corresponding to 131 on the map. Because the purpose of a map like this is not to let you locate specific values, it's to give you the big picture, right? In a map like this, the only elements that you need on the scale is, for example, the minimum value, the maximum value, the median value, perhaps quartiles in between, right? Some meaningful thresholds on the scale, but certainly not all these subdivisions. This is an example of when you let the software make decisions for you, in this case, in terms of putting subdivisions on the scale. And then my favorite part, and again, please be aware, I'm not making fun of the students. I'm making fun of all these choices just because I saw myself in these choices. These are all things, all mistakes that I've made myself in the past. Take a look at this bar graph. I say, why is this damn bar graph so big? Why is it so enormous? It only has 2 damn data points. Why is it so big? Well, I can tell you why it was so big, right? You're designing something quickly, you're designing your infographic, in my case, an infographic to publish in the newspaper, to put all your elements, etc. And then at the very end, very close to the deadline, when you really need to send the graphic to print on the print paper, because I used to work for print papers, you discover that there's a huge hole on the page that you need to fill out with something. And then what you do, you scale that graphic up to fill up that space like that. And that obviously, the size of an object on a page should be proportional to the importance of that object, but also to the density of information that it has. That graphic is super simple. It's only 2 data points. And also, if we make it vertical as it is right now, the error bars become super tiny. It would be much better to make it horizontal, to extend the bars, make them skinnier, and then make the error bars look more visible. So based on that, I transformed that poster into these. This is what you can accomplish by paying attention to design, creating a better hierarchy on the page, creating a layout that looks a little bit more pleasant to the eye with more white space and better organization, and then making conscious choices about how to display things, how to set out, for example, the scale of a map, or how to design a pictorial diagram like the one that we had in the middle. One of the problems that the original one has is that it looks unstable because it's an inverted triangle. So it seems that it's about to fall. If we make it a little bit more rectangular, right, we rounded corner rectangles, we make that diagram look a little bit more pleasant because it looks more stable. It's sitting on something, right? And then I usually like to add pictorial elements to my designs. I decided to add a little silhouette of the mosquito that transmit a malaria. So this is just to point out the importance of design. And then finally, final point, the style itself of the graphics, right? Most of the time, whenever I'm designing a visualization, I design what we could call standard style visualizations, right? Bar graphs, line charts, directly to the data, just the data as clearly as possible, graphics such as these ones. These are not graphics that I designed. These are by the Congressional Budget Office. Most of the time, we should design graphics like these, charts that are more analytical, that let you compare things, it changes over time. But sometimes we may want to think about visualizations that are a little bit more unusual, or that are not aimed, that don't have necessarily an analytical purpose, but more of an artistic purpose. Let me show you an example. This is my friend Jaime Serra. Jaime is also from Spain. He's a very famous graphics designer, long career, much longer than mine. He's perfectly capable of designing graphics like this, like myself, right? But Jaime has a parallel career as an artist. He uses data to create art, all right? And then he frames it and he has exhibits all over the world. Well, one day, Jaime decided that he wanted to visualize how much coffee he drinks throughout a year. Now, if I have to do that myself, the way that I will do that will be to get my coffee mug every day. This is not my coffee mug. This is a Brazilian soda. But in any case, let's suppose that is my coffee mug. I will draw a scale over here. And every day when I pour coffee in, I will measure how many ounces of coffee I'm drinking. I will write that down on an Excel spreadsheet. And then at the end of the year, I will design a time series line chart, right? That will help me see whether there is some seasonality in my coffee drinking, right? Just because I'm thinking analytically about the data. I want to analyze the data and explore it, right? But Jaime wanted to do something different. He wanted to do something that was a little bit more artistically expressive, right? And that had a little bit more of an impact. So instead of designing a graphic with the computer, what he did was to get several large pieces of paper, much larger than these, okay? It was like a tabloid size, right? And then he folded those pieces of paper several times, like I'm doing right now, both vertically and horizontally, to subdivide the page into quadrants, like if they were pages of a calendar, okay? 12 pieces of paper, one per month. And then when he was going to drink coffee, He was drinking the coffee, but he spilled a little bit of the coffee whenever he drank coffee. So part of the coffee accumulated at the bottom of the cup. And then what he did was to get the piece of paper corresponding to the month, and then he positioned the coffee mug or the cup, sorry, on top of the corresponding quadrant of the page to leave a stain on the page. And then at the end, what he ended up having is a physical visualization of coffee drinking month per month from January to December. Now, this is obviously not very accurate. It doesn't serve an analytical purpose. It doesn't help you see sort of like the details of the data or compare one month to the other, right? It doesn't serve that purpose really, really well. If you want that, you need to design graphics like these. But remember that his purpose was different. And by the way, let me make an aside here. Even if this is not very precise and accurate, I can still see patterns in the data. I can still see when he was drinking a lot of coffee in the middle of the year, when he was drinking no coffee in December for some reason. I don't know why. Maybe he was on vacation. We have very long vacations in Spain. Maybe he was on vacation in December. I don't know if he was drinking no coffee. So I can still see sort of like the big picture of the data. But as I said before, his purpose was not preciseness or accuracy, better said, accuracy, right? His purpose was to have a punch, to attract your attention, to capture your imagination, and then lead you to something else, right? Now, you may be wondering, and I know these because whenever I present examples like these to statisticians and scientists in general, I say, well, I will never design a graphic like this, right? All that I care about is graphics like that, just because, you know, the purpose of my work is analysis and precision and etc. I said, yes, 99% of the time that's the case. But 1% of the time, you may want to think about something that is a little bit more unusual, artistic, unique, one-time visualization that has more of like an artistic component. Just for the sake of argument, imagine that you work for an organization and that your organization wants to analyze coffee drinking patterns. And then at the end of the year, they are planning to publish a book to give to visitors and clients, etc., collecting all the data of coffee drinking consumptions, right? Obviously, this is a fictional example, but just for the sake of argument, right? Now, at the end of the year, you publish a book collecting all the numbers. What do you put inside the book? Well, inside the book, you put graphics like these, just because those are the graphics that really give you access to the complexity of the data, comparisons, right? You may want to slice and dice your data in different ways, compare different age groups, different ethnicities, different locations of your company, and so on and so forth, change over time. All those things, all those purposes are well served by traditional data visualizations, as clean as they get. But what do you put on the cover? On the cover of the book, you don't put that, or on the opening sections of the book, on the opening chapters and the page that opens every chapter. What do you put in there? You don't put charts like that, because those look boring, not boring, but they look undistinct. They look like any other type of chart. What you put on the cover is something that is truly distinct, something that is truly unique, and something that is truly yours. So 1% of the time, you may want to think about visualizations that sort of like break the rules or break the mold in a particular way. Anyway, so that's all that I have. However, I'm going to share my slides right away while I take questions from all of you. The last slides in the presentation contains links to tons of resources. I'm just going to go through them very, very quickly. First of all, links to free tools to do data visualization. Now, you're data scientists, obviously, so you should get familiar, get acquainted with the R programming language, Python programming language, and so on and so forth. But if you want to practice really quickly with quick and dirty tools that work on the browser and that are sort of like have graphical user interfaces, you can practice a little bit with some of these. These are some of the tools that I introduce my students to, just because many of them don't know how to code. Therefore, I prefer to use GUIs rather than using code in my classes. I have a page with tutorials in which I teach. I have tons of free videos here, and those videos will teach you how to use many of those tools. And also a tool that is very widespread in the world of visual design called Adobe Illustrator. Every graphic designer knows how to use Adobe Illustrator. I still teach it in my classes, and all the tutorials that I use in my classes to teach data visualization for teach Illustrator for data visualization. You can find it on that page. That's the page about readings about uncertainty. Here you have more readings about visualization, about different types of things. And then books. The last few slides of this presentation are books that I recommend if you want to keep learning about data visualization. Beginning with books that you can find online for free, such as Fundamentals of Data Visualization by Klaus Wilke, which is one of my modern favorites. I think that this book is really, really good. as an introduction, particularly for scientists. Then the famous R for Data Science by Hadley Wickham. And then, books that cover the basics, like my own The Truthful Art or Storytelling with Data by Cole Nussbaumer. Books that go a little bit deeper into the scientific side of data visualization, which probably will be of interest of many of you, such as Visualization Analysis and Design by Tamara Munzner, or Information Visualization by Colin Ware. That, by the way, is the third edition. The book is already in its fourth edition, so it has a different cover now. Books that deal with business analytics, visualization for business analytics, such as the Big Book of Dashboards and many others. The Big Book of Dashboards is one of my favorites lately, just because it contains tons of examples of dashboards that you can get ideas from, right? I'm a great believer in learning by copy, not in the sense of plagiarizing, but in the sense of emulating other people, trying to imitate what the best designers out there do. Books for inspiration, books that can give you, when you run out of ideas, you can get one of these and just browse through them, and you will find tons of examples of great visualizations that you can borrow from. And then, as I said before, books about mapping, because I think that learning a little bit cartography doesn't hurt anyone, right? In fact, if you can take a class about a cartography through, for example, ArcGIS or Quantum GIS or geospatial analysis, anything that relates to mapping and the use of mapping for analysis, I would strongly recommend that you take that class, because being able to design good maps, that's a great skill to have under your belt. That's all that I have. I hope that it was helpful. I'm going to stop sharing my screen. I actually a little bit over time. I apologize. But I'm going to export my slides as a PDF right now, and then send you the link through the chat window. Feel free to download them. And while I do that, please feel free to unmute yourselves and ask any questions you have.
Thank you so much for the presentation. It was really informative.
Yeah, that was a very interesting talk. Thanks a lot.
Thank you.
I was wondering about your collection of uncertainty that you're looking to build. Do you include data where they estimate missing data, things like that? Is that the kind of stuff?
That's a good question, and the answer is no. If you have reading recommendations, papers, etc., send them my way, because I will incorporate. I'm super interested in that. Yeah, because that's another uncertainty. Sometimes I one day should write a book for the general public about all these things, right? Uncertainty, that we have quantifiable uncertainty and non-quantifiable uncertainty also, right? And both of them are part of uncertainty, right? And we need to deal with both, right? And we need to present it to the public and explain it to the public. So I'm super interested in that. So I really appreciate the question. The answer is no, but it was Russell, right, who asked the question? Yeah,
that's right.
So send readings my way, and I will incorporate, if they're freely available online, I will incorporate them to the Dropbox folder, because again, it's something that I'm sending everyone, because it's a public resource.
Awesome, thanks.
I already sent the slides there, so feel free to download them. Yeah, I'm seeing that Yu says the pie chart example is really educative. No wonder in R, it never allows you to draw a pie chart. Well, I wish that it let you draw pie charts. Because again, I mean, a pie chart may be, it depends. It always depends. A pie chart may be a good way. I mean, people understand pie charts. And sometimes a pie chart, this is one of the myths, another myth in data visualization, that visualizations are good or bad in the abstract, and that we can tell whether a visualization is good. And I have changed my mind quite a lot about these. Because I said, if the visualization works, the visualization is good, no matter what you think. If the visualization gets the message through well, and people understand it, that grasp the message, and the visualization doesn't mislead people, it means that the visualization works, regardless of whether you think about that particular graphic form. You may not like it. Many people don't like pie charts just because they think that pie charts are ugly or something, or they are dumb or something. Well, maybe not. If people get messages from them, maybe we should think about them a little bit harder, a little bit deeper, right? Well, yeah, I'm seeing that some people had to leave. Sorry, I ran over time. I didn't time this talk. But yeah, I mean, again, if there are no more questions, I really appreciate it. What do you think that is the most underutilized or underappreciated type of chart or graphic? In journalism, at least, the histogram and the scatter plot. The scatter plot is becoming more prevalent, more visible in news media. But I think that the histogram is one of them. I wish to see more, or I would say histograms or displays of densities in general, or distributions in general. It could be box plots or other types, or strip plots. There are many ways to display distributions. But I wish to see more histograms. There are more though. For example, 538 is using histograms these days, more and more. But I would like to start seeing them also in sort of like news publications that are not aimed exclusively at geeks or nerds, such as 538, right? But more newspapers, etc. Just because, again, I'm a great believer in learning by seeing, and I think that the fact that general readers see those types of charts, if those charts are types of charts are explained to them, they will incorporate them to their own visual vocabulary, right? Besides showing the information through the histogram, we can also use that to teach people how to read a histogram, which is a great skill to have. Effective and ineffective uses of interactive visualizations. Well, that's another book to be written. But I would say that, again, reasoning. It's all about the reasoning. Why? The question is, why do you need interaction, right, when you design a graphic? The default position should be, I think, and again, I've always changed my mind a lot about all these issues, but my current position is that if you don't need interaction, don't use interaction. So if you can show your story with static graphics stacked on top of each other, and you can navigate them just by scrolling them one over the other, do that, and don't make people click, because people don't click. We have some evidence of that. At least in news media, people who read news media, they tend not to click. However, there are certain types of graphics and visualizations that do need to be interactive, right? But if you add interactivity to a graphic, particularly if the interactivity is complex, you better give readers some sort of like reward. So the more you make a person work to obtain the information, the bigger the reward that person will obtain if they interact with the visualization, right? The bigger the surprise, right? So again, add interaction when it makes sense. Add interaction, for example, when you are going to allow people to see themselves in the data, to compare their own lives to the rest of the data set or something like that. I call that the me layer, when we add sort of like a personal component to the visualization. Where am I in this distribution, right? This is the distribution of wealth in the United States, right? Input your salary. This is my salary. You are here, right? That's one of the cases when we can add interaction very, very effectively, just because interaction makes the graphic more understandable, more personable, and also more engaging, is because you are showing myself in the data. So the answer is, do you have a good reason to use interaction? Then use it. Are you using it just because you know how to program in D3 or do graphics in Tableau? Don't use interaction then, because that's not a good reason.
Do you have a particular like favorite kind of visualization, or like a visualization that you don't really like pie charts?
No, not really. I don't have any particular type of graphic that I dislike strongly and non-rationally. But I have some graphics that I really like seeing, just because I enjoyed seeing them for some reason, aesthetically speaking. And again, let me say beforehand that this doesn't mean that these graphics are better than other graphics. They are just graphics that I happen to appreciate aesthetically. I really like strip plots, which are plots that show distribution using little dots, every single observation. I really like those, particularly when you have a box plot overlay that shows you the quartiles of the distribution and the median. I find that sort of like, I don't know, there's something almost cubist in those presentations. They look like abstract paintings, and I really enjoy seeing them for some reason, aesthetically speaking. I like scatter plots in general. So the scatter plot is one of my favorite types of visualizations, again, aesthetically speaking. And I love maps. I love any type of map. I started learning cartography half seriously a decade ago, and the more I read about it, the more I like it. So any type of data map, I usually, there's another book that I don't remember whether I mentioned it in the in the slides called Cartography by Ken Field. He's about to publish the second book in the series called Cartography 2, not very original. But if you can find that book, try. It's a great collection of maps, and I really enjoy that book, Cartography by Ken Field. Yeah, great book.
I have another question too. If
Yeah, go ahead.
some of my traditional data viz books seem to discourage me from using different visualizations for the sake of variety. But my personal experience as a UX designer is that it can be very engaging to switch things up. And so I was just wondering if you've had experiences with that, what your opinions might be.
Yeah. Yeah. I feel your pain because I've been in the same situation. The theory tells you don't vary the type of graphic gratuitously if you're presenting the same type of data. But then if you don't do that, then your graphic is going to look flat. Look, in design, we always talk about the balance between unity and variety, right? If you only care about unity, your compositions are going to look very cohesive, stylistically speaking, but they're going to look completely flat and nothing is going to be distinguished. Varying the type of graphic, right, may help you add a little bit of variety to the page and visual interest. So what is the answer to that question? The answer is that it depends on the type of visualization that I'm designing. If I am designing a business dashboard, then I don't vary the type of graphic gratuitously. If I have a series of line charts, all of them are going to be line charts, just because you want to see the performance of your company in different markets. All of them should be line charts. And if people, the first time they see the dashboard, they complain for the lack of variety, they will not complain anymore after 1 week or two of using the chart because they will get used to it, right? However, it is different when we publish visualizations that are one-time visualizations, like an infographic in a newspaper or whatever. Then I would think about adding some variety to the page, depending on what my aesthetic feeling is. Sometimes I love to see an entire page, just filled with small line charts per state. I love that because again, it looks like a mosaic or something. It looks beautiful. But in some cases, in a completely different section, right, you may want to use a different type of chart. What is the key there? That you don't mix them up, right? That you sort of like vary the type of graphic when you jump to a completely different topic within the same page, right? So if you have, for example, a comparison of unemployment rates, and then you have a comparison of poverty rates on the same page, right? You can use, even if both of them show you are time series charts, right? You may want to use one type of graphic for the displays of the unemployment rate, and all of them together will be the same type of graphic. But then when you go to display the unemployment rate, you use a different type of graphic, perhaps a series of bar graphs, just because your data is not completely continuous, but it's month by month or something. And then you use a series of bar graphs, right? So you preserve the consistency internally of each one of the sections, but you add variety by changing the type of graphic in a completely different section. But I will not change it in one of the sections itself.
Thank you.
All right, it's almost 7 p.m.
Yeah, it's
oh well, it's earlier over there, obviously.
Yeah. But I think we can wrap up soon, like whenever you're ready to wrap up.
I actually need to wrap up, but if there's another quick question, go ahead. Yeah.
Are there any last minute quick questions, anyone? Because I think we can wrap up now. Okay, I don't think. Thank you so much for coming and giving this presentation.
Sure, my pleasure. Thank you for inviting me.
Yeah.
Download the slides and use them. Take a look at those materials. Get started. We need more people doing better visualizations.
Yeah. I actually do have one last quick question. Do you have like any advice for someone interested in like starting off in data journalism or like getting into that?
Actually, yes. And it's not advice that is applicable right now during a pandemic. But it's to start making connections in that world. And the best way to make connections is to attend a conference physically. The problem is that, for example, there's a famous conference, a very popular conference in data journalism that happens every year called NICAR. I'm typing it. IRE NICAR is investigative reporters and editors, and NICER is the national something. I don't remember what the acronym stands for. This is the annual conference that gathers all the biggest names in data journalism in the country. So it's a great place to start making connections. Engage with your, for example, is there a university paper at the university? Produce work for it. So that's the first thing that you should do. Get engaged with the local paper. Get engaged with the first of all with the student paper, with the university paper, and start producing visualizations for that. Many people who ended up working in data journalism in news media began doing data stories for university newspapers, creating a portfolio. You need to develop a portfolio, right? And in order to develop it, you need to start doing actual work that it has been published. And then, if possible, try to place a piece in the local paper. It may be possible to offer a story to the local paper and see whether they are interested in publishing it, and then you will try to produce it. There will be another, but that should come after you work for the student paper, so you have something to show, to demonstrate that you can accomplish that. So it's a step-by-step process. You start sort of like climbing up the ladder. You begin here, then you continue here, then you continue here. And then keep practicing and do projects that are about topics that you care about, even if they are not going to be published anywhere. You can create them for yourself, or you can try to pitch them to organizations such as the Pudding. So the pudding.co. The Pudding is a collective of data journalists and visualization designers that publish what they call data essays. Right? They collect data and they present interesting stories about different topics, and they accept suggestions. They accept work from external people, so you can pitch ideas to them. Placing a story in the Pudding, that's big, that's huge. If you can do that, it will give you a lot of visibility. Produce work, show your work, get feedback from the rest of the world, engage in the visualization community, get engaged in the Data Visualization Society, for example, which is a free organization that exists right now.
Yeah.
Interact with people. That's the way to go. Do it little by little. But the key thing is produce work and begin as soon as possible, beginning with the student newspaper.
Great. Thank you.
Mm-hmm.
And I think we're going to end it here. Thank you, everyone else.
Thank you. Take care, everyone.
Thanks.
Stay safe. Bye-bye.
Thanks. Bye.
Thank you.